Step 4. Can we actually stop aging?
Oliver and Lily explore the information theory of aging and explain how our bodies are like scratched CDs that can be polished to become young again.
Hello, everyone. Welcome.
Hi there.
I'm Oliver,
And I'm Lily.
and this is Science in Easy English.
Yes, welcome.
Today, we are asking a big question.
A very big question.
Can we stop getting old?
Ooh, okay, Oliver, imagine if you could be 20 years old again.
20 years old. Wow.
Is that possible? Or is it, just a story from a movie?
That is a great question, and it's exactly what we're going to talk about today.
Okay, I'm ready.
So today, we will look at a new scientific paper.
Mm-hmm.
And this paper says that aging, getting old,
Mm-hmm.
it's not what we thought.
Really?
It's not just wear and tear. It's not just the body getting tired.
Okay.
We will learn how scientists made an old mouse young again.
Wow. A young mouse from an old mouse.
Exactly. And as always, we will use easy words. We will speak slow and clear.
So everyone can understand.
So even beginners can understand some deep science.
Perfect. Let's start.
So, Lily, what do you think aging is? What's the common idea?
Well, I think aging is like an old car.
An old car. Tell me more.
After many years, the parts they break.
Right.
Things get rusty, the car gets slow, it just stops working. Our bodies are like that, right?
That is a perfect way to say it. And that is the old idea.
A wear and tear theory.
Exactly. People thought our bodies just wear out like a machine.
Huh.
But this new paper, it has a new idea.
Okay, what is it?
It's called the information theory of aging.
Information theory. Okay.
The paper says the body does not run out of parts.
No.
No. It says the body runs out of information.
Information? What does that mean?
It means the body.
Yeah.
It forgets how to work.
Forgets, like my brain forgets a name?
Yes, something like that. The cells in your body forget their jobs.
Huh. That's a very different idea.
It is. And the paper uses a great analogy to explain it.
An analogy.
Yes, a comparison. It compares our bodies to a CD, a compact disc.
Oh, a CD. For music, I remember those.
Me too.
Yeah.
So think about a CD. There are two parts.
Right.
There's the music,
Yeah.
the song, and then there's the CD player that reads the song.
Okay. Music and the player. Got it.
In our bodies, the DNA is the music.
Our DNA, the instructions inside us.
Exactly. And that music's digital.
Yeah.
It's like, zeros and ones. It lasts forever.
Forever.
Well, for a very, very long time. Even in very old people, their DNA, the music, it's still good. It's still there.
Okay, so the music is not the problem.
Correct. The problem is with the other part, the analog part.
The CD player.
Yes. Or maybe the surface of the CD itself. In our bodies, this is called the epigenome.
Epigenome. That's a new word for me.
It is a science word, yes.
What is the epigenome?
The epigenome is the reader. It reads the DNA.
It reads the music.
Yes. It tells the cell which song to play.
Which song?
Well, think about it. Every cell in your body has the same DNA, the same music library.
My skin cell and my brain cell have the same DNA.
Exactly the same, but they do different jobs.
Right.
The epigenome tells the skin cell to play the skin cell song, and it tells the brain cell to play the brain cell song.
Ah, I see. So it's the boss. It tells the cells what to be.
A perfect way to say it. It's the boss. But what happens if the CD gets scratched?
Oh, I know this one. The music skips.
It skips. Or it sounds wrong.
Mm-hmm.
Or maybe it stops.
Yes.
The paper says aging is like scratches on the CD.
Scratches on our epigenome.
Yes. Over time, life makes these little scratches. And the reader, the epigenome, it gets confused.
So the music is still good. The DNA is okay.
The DNA is still perfect,
Yeah.
but the reader can't read it correctly.
So the cell gets confused.
The cell gets very confused. It loses its identity.
Yeah.
It forgets if it's a skin cell or a brain cell. It forgets its song.
Wow. So that's what makes us old. Confused cells.
That is the new idea. Millions of confused cells.
That makes sense.
Yeah.
But how do scientists know this is true? How can they prove it?
Great question. This is where the mice come into the story.
The mice. Okay.
Scientists did an experiment. They used something called the ICE system.
Ice. Like cold.
No, ICE, there's just the name. What they did was they wanted to create scratches on purpose.
They wanted to scratch the CD of the mouse.
Exactly. So they took young, healthy mice and they cut the DNA in their cells, just a little bit.
They cut the DNA. I thought the DNA wasn't the problem.
You are right. And this is the clever part. They did not change the DNA code. They didn't change the music.
So
What did the cut do?
it made a distraction. Imagine there's a small repair team in the cell.
Okay, a repair team.
Their main job is to help the epigenome, the reader. But when there is a cut, they have to run and fix it.
So they leave their job to go fix the cut.
Yes. And the scientists made many, many small cuts, so the repair team was always busy, always running around.
And they couldn't do their main job?
Right. They got lost. They couldn't go back to the right place. And this created the epigenetic noise, the scratches.
I see. So they made the reader confused on purpose.
Yes. And what happened to the mouse?
What happened? The young mouse.
Yeah.
It got old very fast. It got gray fur. It became weak. Some mice even went blind.
Just from these scratches.
Yes. This proved that it was the scratches, the epigenetic noise, that caused aging, not broken DNA.
Wow. That's amazing. But it's also very sad for the mouse.
It is a bit sad, yes.
So, can we fix the scratches? Can we, polish the CD?
And that is the best news from the paper.
There's good news.
The best news, the answer is yes, we can.
We can polish the CD.
Yes. The scientists found that the cell has a backup copy.
A backup copy of what?
A backup copy of the original information, the clean, unscratched information.
The cell remembers how to be young.
It seems so. It has a memory of the perfect song. We just need to help it find that memory.
And how do we do that? What is the polishing kit?
The polishing kit is a set of special genes. They're called Yamanaka factors.
Yamanaka factors.
Let's just call them a reset switch.
A reset switch? I like that.
So the scientists took the old blind mice.
The ones with the scratches.
Yes. And they gave them these Yamanaka factors. They used them like a medicine.
They pushed the reset switch.
They did. And what happened was incredible.
Don't tell me.
The mice did not just stop aging.
No.
They went backward.
Backward.
They got young again. The blind mouse. It could see again.
Could see again. No way.
Yes. Its eye nerves, they grew back. Like a baby mouse.
That's impossible. Nerves don't grow back.
Usually, no. But with this, it was like rebooting a computer.
Rebooting. Starting again.
Yes. The cell read the backup copy, deleted the scratches, and remembered how to be a young, healthy nerve cell.
That is maybe the most amazing thing I have ever heard.
It is amazing.
Can I do this now? Can I go to the store and buy the reset switch?
Chuckle softly. But no, not yet.
Oh.
Right now, this is still in the lab. It's only in mice. It's not ready for people.
Why not?
Well, it's very powerful. And it could be dangerous if it's not done perfectly. We need more research to make it safe. I see. Okay. So, no reset switch for me today.
Not today.
Yeah.
But the paper does say there are things we can do.
Things I can do now.
Yes. Things that help make the scratches happen slower.
Oh, okay. Like what?
Well, the paper talks about things like fasting.
Fasting, not eating.
Yes. Eating less often. When you fast, it helps the reader, the epigenome, to stay focused and clean itself.
Interesting. What else?
Something called cold exposure.
Being cold, like a cold shower.
Exactly like a cold shower. Being cold for a short time can wake up that repair team in your cells.
The team that fixes the scratches.
The very same one. And the last one is exercise.
Of course, exercise.
Yes. These simple things, they don't reset you to 20 years old.
Right.
But they help slow down the scratching. They keep your CD cleaner for longer.
Okay. Fasting, cold showers, exercise. Maybe I can try one of those.
It's a start.
Phew. That was a lot of new information.
It was. So let's go over the most important new words. This is our keyword section.
Okay. All right.
The first word is genome.
The genome is the instruction book inside us. It's our DNA. And it's digital.
The genome, the instruction book. Got it.
Number 2, epigenome.
Epigenome. That was a tricky one.
Yes, the epigenome is the reader. It reads the instructions in the genome. It's analog.
A reader. Okay.
Number 3, cell.
Cell. I know that one.
And what is it?
It's the very, very small building block of our body.
Excellent. Number 4, aging.
Aging. Getting older.
Yes. Or we can say it's when the body stops working well because of the scratches.
Because of lost information. Okay.
Number 5 is reboot.
Reboot, like a computer.
Exactly. To start a computer or a cell again from the beginning.
Reboot.
And the last one, number 6, reprogramming.
Reprogram.
This means changing the instructions to make the cell young again using the reset switch.
Reprogramming. Polishing the CD.
You've got it. Okay, you ready for a little test?
A test. Uh-oh. Okay, it's our mini quiz.
That's right. Question 1. Is aging caused by lost DNA?
Lost DNA. The paper said the DNA of the music is still good, so.
Right. That's correct. So what is it caused by?
It's caused by the reader, the epigenome getting confused. by the scratches.
Perfect. Question 2. What analogy, what comparison did we use for aging?
Oh, that was my favorite part. A scratch CD.
A scratched CD. Excellent.
Where the music is good, but the player can't read it.
Exactly. Last question. Question 3. What happened to the blind mouse in the experiment?
This was the amazing part. The blind mouse. It became young again. And it could see again.
It could see again. Fantastic. You get an A+.
Yay!
Okay, so let's wrap up for today.
Yes.
Today we learned a new idea about getting old. Aging is not broken parts, it's lost information.
Like a scratched CD.
Exactly. We learned the scientists can polish a CD. They can use a reset switch to make cells young again.
In mice.
In mice, yes. For now, but it is very exciting.
It really is, I think. I think I will try a cold shower tomorrow.
Really.
Well, maybe just for 1 minute.
That's a good start. Thanks everyone for listening to Science in Easy English.
See you next time. Bye!